Good afternoon, everyone. My name is Frank Sullivan. I'm the Marketing Director for Digital Craftsman, and today I'd like to introduce two special guests. On the show, we have Mikhail Drescher, Senior Solutions Architect,
Good to meet you again.
Simon Wilcox, Managing Director of Digital Craftsman. Gents, hello, and thanks for coming on the Digital Craftsman show.
No problem.
Over the last 4 videos, we've explored security. We've looked at small-scale things to be implemented like identity and access management, multi-factor authentication, all the way up to the big strategic stuff, how to plant fire drills. One of the most important trends, certainly that we see coming, is security as a service. So my question to both of you, starting off with you, Simon, is security limited to the office of the CISO?
Certainly shouldn't be. For smaller types of companies, the skills that you need and the active skills that you need may be beyond the budget of smaller companies, even those with sort of a few hundred employees. The advantage of using a managed service provider is that you're tapping into a wealth of experience across a load of different customers and problem spaces. As they say, you've got to be, for those we're trying to keep people out, we have to be successful every time, and they only have to be successful once. So using the best set of skills that you can get your hands on is going to be a benefit. The office of the CISO at that point is around setting the standards that they expect, looking for the gaps, making sure that the business itself is bought into it, and that there are awareness schemes and so on happening around the business.
So we have a number of financial services customers with mission-critical applications that we maintain and protectively monitor. What do we mean by protective monitoring? Where does the responsibility end for the customer and start with us?
Well, it's a shared responsibility model. We tend to be responsible for the monitoring of the network and the activities there, so proactively looking for intrusion attempts and so on. But there is still the responsibility of the customer to ensure that their applications are secured from people exfiltrating data through the application. So the application there upwards, usually the responsibility of the customer, but everything from the operating system downwards is us. And obviously if we're then in the public cloud, there's a shared responsibility with the cloud provider for the physical security and the other things that they provide at the very bottom of the stack.
I mean, Mikhail, in a previous discussion with Simon, we talked about the spectrum of being the guardian of governance versus being the custodian of data, and how those two fit together. Tell us a little bit more about how we manage data egress.
That's highly dependent on the actual customer. Some customers in the medical field have different requirements, regulatory requirements, for example, than customers in the supply chain industry, for example. So that really depends on looking at the surrounding, at the environment you're in, looking at the requirements, looking at the actual regulation. If you look at GDPR, for example,
to speak up a little bit.
There is, for GDPR, there is a very good guideline that everybody can look at, and that's been published by the Information Commissioner's Office in the UK. It's an 8-step guideline, if I'm not mistaken, that looks at the central questions on data austerity. Something where you have to look at, do you actually need the data that you're collecting, and for which purpose do you need, and what do you do with that data? It's central questions that shouldn't be hard to answer, yet can have profound changes in how you actually run your business.
Unless you're talking to the marketing department, in which case data poverty is our worst nightmare.
Yes, that's true. But let me hijack this a bit. Simon talked a bit about data governance and operational security. There is service security as well. If you look at, for example, in a managed service environment or in a cloud environment, you often use services that are off the shelf, that are provided by your cloud provider, or that are provided elsewhere and managed and hosted with value add. But in terms of service security, there's an interesting aspect that is counterintuitive to keep your login vetting of data or login vetting of logins within your premises or as the most guarded part is actually outsourcing that. Meaning, if you outsource that to a trusted provider, the trusted provider all of a sudden gets a scale and an insight into trans-organizational attacks that you otherwise would have no idea and no chance to get.
Trans-organizational attacks?
Yes.
What do you mean by that?
I mean with that, but they can detect patterns in attacks on identities, on applications, even login attempts. What's typically known as rainbow attempts, where people try to use a randomly generated password with a login name. They can detect it very easily, but if attackers spread that over organizations when they have purchased a set of passwords, you can get them on online markets anywhere, really. It's hard to detect on an organizational level, but easy to detect when you all of a sudden manage the identity provisioning for, say, 10, 1,500 or thousands of organizations.
Very good point.
That is one of the added values or benefits when you use Google, for example, as an identity provider. Google has hundreds of millions of accounts under their control. In terms of vetting the identity of a person, Google is an identity provider for many different services.
They have the scale to be able to
They have the
detect
scale, exactly, and they have the ability to detect it worldwide. And patterns that any small company with 20, 50, 100 employees having their own identity provider, they simply don't have that.
I'm glad you mentioned server-side security. The next topic and trend number 2 that we're going to be talking about is, sure to put a drum roll in there, hybrid cloud.
Yep.
Is hybrid cloud a stepping stone into public cloud?
It certainly can be. We're tending to see hybrid cloud at the moment as solving a problem around compliance and data sovereignty more than anything else at the moment. So as trust in cloud increases, I think we'll see more people moving to everything in the cloud. But again, as we talked about in one of the previous videos, there is some roles just aren't suitable for putting in the cloud, and often databases, long-running databases are quite often that in one of those things which may not be suitable for putting into the cloud. The data sovereignty issue is really one of knowing that you have a copy of your own data. If that is a major issue for you, as it should be for most businesses, if you're entrusting everything you have, with all your eggs in one basket, and there's a problem there, how do you recover from that? How do you get back to it? You should always be having another copy of the data outside of the primary place where you're using it. And in some cases, that's just replicating from one data center to another, if it's all in private cloud. If you're using public cloud, it may be that you want to take a regular backup of that, or to mirror that database down to a database that you own, so that you know that you've got a good copy of that data should you ever need it. And really, some of the customers we're finding they're taking advantage of the kind of ephemeral nature of application servers and web servers and so on, and they're putting those into the cloud and allowing them to scale up and down, but then keeping their database servers tightly within their control, and then which is the hybrid cloud model, blending the on-prem or the private cloud infrastructure with the scalability of the public cloud, and perhaps also testing out new applications and new services in the public cloud before committing to any kind of CapEx spend. So you can try out data lakes, you can try out AI and machine learning and so on, those sorts of topics. Very easy to test, to set up a development environment in the public cloud and try those things out. Even if you might think you might want a copy of that locally, you can do it. You can do the dev work in the cloud and then do the CapEx for the private cloud later.
We've had some pretty deep discussions, certainly you and I, and some other more strategic discussions about how we view hybrid cloud across digital craftsmen. some of us are in the camp where if a customer were to come to us and say hybrid cloud is our default operating model, we would turn around and have them sectioned under the Mental Health Act because it's not a real thing. Or is it? Is hybrid cloud a legitimate operating
Absolutely.
model?
Yes, absolutely it is. As I say, there's there are plenty of good reasons for wanting to own some of that data, some of those processes back in the cloud, in your own data center in a hybrid manner. We also see there are certain types of hardware, for instance, if you have a particular type of requirement for some sort of hardware security module, or there's some particular specific bit of hardware that you have, that can't go to the public cloud. There's nowhere to put it, so you have to have some part of your own cloud to attach those products to, those proprietary products to. So from that sense, I think hybrid cloud is very useful. I think there will also there's also a slight difference between the on-premise version of things like Microsoft SQL Server and Azure SQL Server. They are slightly different. They have different capabilities, and sometimes you may need to use the on-premise version to get access to particular types of functionality. It's getting much closer. It's only probably an iteration or two away now from them being pretty much indistinguishable, but there are still some differences.
Mikhail, I'd like to lean on one of your lesser-known specialisms, and that's policies on interoperability and the portability of workloads between providers. Surely, one of the great commoditizing influences over public cloud, or cloud in general, is is how homogeneous the set of workloads are across data centers or across different organizations. When do you think we'll start to see true interoperability or truly frictionless portability between public and private?
There are instances where true interoperability, technical interoperability between cloud services has already been achieved. There are pundits in the cloud who say it is already a solved problem. I tend to be one of them, that it's more a business model that prevents interoperability in the sense of the energy market. As you see when you switch your energy provider, that's a big goal. That's a big goal in the policy and regulatory market.
We talk about financial interoperability versus...
No, we talk about technical interoperability. Technical interoperability, where transporting the business model of when you run a data center, you have redundant energy providers, you have redundant network connectivity providers. Why not, when you run IT or IT workloads, why not have redundant cloud operators? As a risk mitigation strategy, we are not there yet, it's not there yet, but on the regulatory level, the European Union has recently put on the free flow of non-personal data regulation, which comes into force, or is into force since March this year, and has launched a self-regulatory process in the industry with, if you look at the participants, it's the who's who is in there. And by November this year, end of November 2019, the industry is required to put code of conduct into force, by which they pledge how to transfer data and port applications in the cloud. It doesn't mean that it's seamless or transparent interoperability. It means enabling an easier way to migrate from one cloud provider to another, on the road to actual large-scale international full interoperability in a way how the energy market works. At the flick of a finger, you switch from one provider to another. That technical interoperability has already been solved.
True commoditization.
Yes. This is where we're heading, that public cloud becomes a commodity, and with that unlocks actually a huge potential of cloud usage that we've never seen before.
Second wave, so to speak. So we've talked about legitimate use cases where hybrid cloud should be the default operating model. We've looked at some of the more loony fringe theories about technical interoperability between vendors, of which I support. I just think it's your view is very optimistic. It's going to take a long time for vendors to catch up.
I have a slightly contrary view to that.
Yeah.
Yes, to a certain extent, a lot of that stuff is done. VMware have been running on top of AWS for a while. They're now running on top of Azure quite natively. So you can now use VMware tools across both those public cloud providers, and it's all integrated together, so you can move a workload from one place to another. That's all fine. Lots of people are using containers and doing things like Python-based containers for microservices. You can drop those into either or any public cloud provider pretty much. There's a gateway for those. Kubernetes is now pretty much ubiquitous. Yes. Where it goes wrong at the moment is when you start using platform-specific services of one of the public cloud providers, because at that point you're then locked into that provider. You can't be easily moved from one to the other.
That's true.
So what I hope we'll see at some point is an abstraction layer across those common services. So, for instance, Amazon has auto-scaling, Azure has a similar thing. Ideally, you want a vendor-agnostic interface to that, so it doesn't matter which one you're using in the back end. Some of those things are coming. Terraform does a little bit of that, so you can set up instances or infrastructure as code in different senses, and it uses the right thing underneath. But you still have the same problem with the platform services. With Amazon, I think they were trumpeting 189 services, if I remember rightly, at AWS Summit recently. If you start using all of those, you're tied into Amazon, and there isn't much you can do about that. So it's an arms race for those guys to get the most services available to tie people in. So I think whilst at a technical level, infrastructure can be easily moved.
You mean like
I
a
think
Linux box is a Linux box is a Linux box.
Exactly. And a Docker container is a Docker container. You can run that pretty much anywhere.
Yeah.
You've even got things like you've got Lambda functions and so on are starting to tie people into them because there's a slightly different interface. Although there are some. And Danny Kang goes to talk on that at our last event.
We'll include a link to that talk in the description below.
So he's having to talk about that in terms of they're working on a framework that works across multiple clouds to abstract away some of the detail about those Lambda functions. So they're all written in Python mostly. So if you run it in Python, they'll abstract the layer. So there's so you can plug it into any one of those clouds. So that's quite an interesting framework, and I think it's got a lot of potential. Certainly that gets you some of it, but the deeper into the services you go, the more tied you are to public cloud provider.
Okay, cynical view here, if I may. Containers, a new way to run old stuff in a new place. Yes or no?
Yes, largely. It's interesting. It's an interesting development with the rise of kind of DevOps, and that it does mean that the developers have a lot more control over the environment in which their code is running, and the operations end of DevOps spend their time in optimizing the host architecture to make sure that you've got the best piece. So that's a good move. I think you've still got similar sort of problems in terms of making sure that they're properly orchestrated, making sure they're properly secured, and so on. Docker doesn't really fix any of those problems, nor does Kubernetes. Or any of the other orchestration tools don't really fix that. There are a lot of people who are working now, there's a lot of money, a lot of VC money is going into software to try and fix some of these problems. So it's a bit Wild West out there, but it's getting better.
That's great insight. Final question on containers as our third big trend for the coming period. Does the containerization of an application have more to do with the people on the ops end of DevOps, almost to the point that it takes away from it takes away the responsibility for the developer to write scaling policies into something that was designed to be cloud native? I'm sure we can find numerous examples of that in customers or applications that have been written. But do you not feel that containers containers as the great equalizer promised to democratize where you could run your workload, and hasn't really lived up to that promise.
That promise was given and solved by virtual machines already. But the biggest, on the technical level, the biggest difference between containers and virtual machines is that the virtual machines are trans-operational and trans-architectural. Means that you can run in the extreme Linux operating system in a virtual machine on a Microsoft Windows host, or vice versa, or AIX or whatever. So this you have a trans-architectural encapsulation. That's for virtual machines. Containers don't do that. Containers live in the same operation system environment, but they shield processes from each other. And they solve one thing that has never been properly solved in IT architecture and enterprise architecture, and that's commonly known as dependency hell. When I write software, I use many different libraries, and when I deploy many different applications on the same host, they often require the same library in a different version. And how to resolve that? There are many, many different architectures. Java 2 Enterprise Edition is one way to solve it without virtual machines, without containers. Containers are a very lightweight way of solving that, and this started the whole movement of actually much more lightweight, much more agile way of operating and developing software. This is how DevOps came to be. This is how microservices and microarchitectures came to be. And serverless or Lambda functions, if you like, are just the next step, and that you don't, for certain ways of doing software, you don't need the environment. The only thing you're interested in is a certain transaction. That's encoded in your function.
Do you feel that the way in which software is getting written is eroding or sort of blurring the lines between what a systems administrator should do or what they shouldn't do?
System administrators write software. Shell scripts, are software. Okay. Configuration is software.
Sure. So, let me be more specific in my point. When it comes to writing infrastructure as code, whose job is that in the organization?
I think it's a split responsibility. I think between the people who are responsible for the operations, so the ops and the DevOps, and the developers. So typically, I think you would find the operations end defining a lot around the specifications of machines in terms of the operating system that you're going to run Docker on top of, or the different standards that things need to comply. Having the base images on which you base your Docker images, those would be maintained by ops, and then they're maintaining and monitoring the systems when they're actually in production. So I think those, there is definitely a split between them, but the ops team has to enable the development team to be able to do what they need to do quickly, whilst maintaining those standards across everything. I think if you end up with just letting developers run riot with Docker and the master containers and so on, little bits and pieces, then it doesn't. Then you're going to have a problem.
We're not going to mention the procurement department here.
No.
Problem number 4, or trend number 4 that we're starting to see as we become more sophisticated in our approach to monitoring and security as a service is around IHOPs. It's the use of data, consumption data, billing data, log data, security data, used to devolve decision making back down the line. Whether it's scalability, whether it's around performance enhancement, cost management, or cost optimization. We're seeing an increasing number of players in the sort of cloud tools and services space, like New Relic, Science Logic, Scalar, Cloud Health. To what extent are those players really, to what extent are enterprise cloud users ready to use those tools in anger? It seems like they're years away from actually using them. Some of them are ahead, but being the industry veteran that I am, the
this is a buzzword bingo that we've seen before. I think at the moment AI is largely a solution in search of a problem. There are lots of quite cool tools out there, but they're potentially quite hard to train. And if you don't have a large amount of data, both positive and negative, they can be very difficult to train. I think that's where perhaps the scale of the MSPs will start to come to play, where we're aggregating a lot more data together to provide a training set or a set of positives to train the systems against. Most machine learning stuff at the moment tends to be a lot about reinforcement learning. You have to tell it what good looks like, and then it can spot when it doesn't look good. And so there's I'm not convinced at the moment exactly what use a lot of those systems are going to be, but we've seen before some things can come in and disrupt industries very quickly. So if someone can provide a really valid use case for a piece of software, you're going to see it taken up very quickly. I think my other big problem with a lot of this is around the explanation of what it's doing. It's not so bad if we're taking sort of security decisions about blocking things or not blocking things based on application traffic. That's quite interesting, but I think once you start making decisions, particularly if those decisions involve personal data, I think you need to have a much more transparent audit process for what those AI processes are actually doing.
I mean, what we're talking about is pretty basic machine learning techniques. We're not talking about Ray Kurzweil's concept of a singularity running your cloud infrastructure.
We're a long way from that.
We are a long way from that. And yes, I do believe AI washing, in the same way that cloud washing was prevalent 5 years ago, is not a great thing for the industry. But nonetheless, my marketing colleagues and counterparts in other businesses have still latched onto a problem, and it's that we're creating a lot of consumption data.
Yep.
That consumption data can be mined and refined into something usable. That can then derive actionable insight, and then that can reinforce decision making either by the MSP or by the IT ops team within the customer organization. I guess my question is, to what extent is this data actually going to be used to drive decision making? Are you going to have auto-scaling policies? Are we going to, at worst, am I going to have to open up a ticket because I want more horsepower?
I think a lot of the problems that AI claims to solve are easily solvable by other means in a lot of cases. So
blockchain versus a database.
And I think what we need to find a proper use case for those systems in terms of predicting things that we haven't otherwise seen. So finding relationships between things, one thing and another. So we've talked before about the digital twin model, where we've got a computer model of how our system should be behaving, and then we compare that to the real life model, and we try to see where the real life model is different from the computer model, and is that the computer model that's wrong, or is reality that's wrong? And I think
you're a real bloodhound with a bone when it comes to
absolutely
digital twinning.
Certainly am. And I think we'll see a lot of that. I think there's also AI can potentially help. But it's still not really AI, it's statistical analysis of data patterns. So classic example would be, somebody deploys a new version of the code, and suddenly it's throwing up high load peaks and so on across a large number of machines. And AI can see that, but really it's only statistical analysis of the traffic that you're already seeing. So is it really that different from a lot of the tools that we currently have? Not really so much for a lot of our area of interest right now, anyway.
A couple of days ago, somebody approached me on LinkedIn saying that they had this AI lead generation thing for LinkedIn, to which my immediate response was, no, that's a lie. What's your concept of AI? And actually his response was beautifully honest. He says, someone's got to sell this shit, so we'll call it AI.
Yeah, exactly. Yeah.
But the confusion was the difference between what is considered artificially intelligent and sentient and conscious, the academic viewpoint, versus what's good old automation. And we all know that the fifth and final topic we're going to talk about is automation. We all know that it's already here. It's already changed the way that lawyers work. It's changed the way that manufacturers work. It's changed the way that we drive cars. It's changed everything. We're going to leave the politics and the productivity aspect of this out of this discussion, but I want to look at a fundamental question. Are the robots coming for my IHOPs job?
No,
Yeah.
No?
they're not.
No. No, but you're assuming that I have the grit and the wherewithal to transition my skills from being bash scripter to vendor performance manager. I don't want to do that. I like moving stuff around the data center. I don't want to have to go and learn a whole new set of skills. Death of my career? Maybe, maybe not. I guess when that happens at scale, where people start using the data and DevOps and auto-scaling rules and all of that automation gets built into the software, what need do I have for an engineer monitoring it and pushing the buttons on the other end? More importantly, why would I need a managed services provider if all of that is built into the application layer?
Actually, I think it becomes probably more important to be using an MSP at that point. And one of the things we talked a bit earlier on about the skills that we have available to use across, whatever. I think it's the more automation there is, the less need there is for having those very skilled resources immediately available to hand. So the more important it's going to be to have those skills available when you do need them. So I think MSPs have become really quite important at that point, because inevitably something will go wrong.
Yeah.
And there isn't really there's no real way around that. So having access to those skills to do the troubleshooting when something does go wrong is where an MSP really comes into its own.
Who fixes the robots when the robots break down? You're always going to need a skilled human. Mikkel, what is the human's involvement in the automation of infrastructure? What is, is it continual certification? Is it, good practice to be consistently upskilled and trained on new technologies? I mean, how does the human factor keep up and intermediate itself back into this whole trend? And that's all we've got time for. No.
Thank you. It's undeniable, I think, that more and more will get automated. The areas where I think automation ought not to take place is oversight, high-level decision-making, association. It becomes very, very quickly transcendent, but things like empathy in taking decisions is something that machines never will be able to do. Taking a decision and deviating from a hard-code set of rules that a RETI engine will take care and say, no, I will turn off your life support system, is something that humans are superior in that to machines.
It's quite a philosophical point. At what point can computers simulate mirror neurons, and how do we replicate empathy in software? That's probably for another episode. Final topic we're going to be talking about is the consolidation of the cloud channel. And something has happened, and it's not a branding error. The Amazon Web Services Partner Channel changed its name to become the Solutions Providing Program. Perhaps something sinister, something very helpful? Are we looking at MSPs becoming more value adders to the code and trying to get rid of the bare metal managers? What's that all about?
I think it's got to be going in that direction. You were talking about just earlier there about automation, thinking about jobs. With the rise of public cloud or managed private cloud, the need for server managers, so systems administrators who look after servers and businesses, is dropping. So people coming into the industry now, young new entrants to the industry, they may go through a large part of their career, if they start at a reasonable sized company, never really looking at tin at all.
Mm.
So those are new.
They'll never know the joys.
Yeah, exactly. Lucky people. So I think there is a change already. There is already a sea change happening right now, where understanding what you can do with the infrastructure and how to use it to solve problems, to be solution providers, is where MSPs are going. Yes, there will always be or at least always the life of my career. There will always be a need for people to manage tin. There will always be tin that needs to be managed, and MSPs will do a good job of doing that. And I think at the same time there will always be lots of cloud-based infrastructure that needs design and management and the governance and everything else around it. So I think there's always a role to play, the MSP to play in that situation. So I think it'll be be interesting to kind of see how that changes over the years. But I'm pretty certain that there's still a big use for MSPs, with our skill sets changing, to support customers on their digital journeys.
Well, it's a logical conclusion where we know for a fact that customers are investing less and less in upskilling around infrastructure, but MSPs are investing more and more in training and certification to keep up with the vendors in order to maintain their resale contracts. Therefore, the logical place to go is an MSP.
Absolutely, yeah. And Amazon's are still. They're not interested in doing that work themselves. They don't want to do that. They work with the channel. So when you do contact Amazon, they're looking to they're doing demand generation, but they're looking for that for their partners. So which are MSPs and solution providers and ISVs and so on. So that's likely to only grow. I think. Well, we won't see Amazon going directly into managed services. I don't think that wouldn't be a wise move for them, or indeed any of the others. So it's always going to be partner based, and the less of that skill you have on site, the more likely you are to get someone in to do it. I mean, if you think about the air conditioning in your building, you don't know how that works. You just call a guy when you need it to be fixed, or they come in and they maintain it. So service providers in lots of different places. We're now moving beyond computing as a special thing that is going to, in its own right, give you advantage. It's now the applications that run them, and they can run in the cloud, and that still gives you advantage. So you don't need to know how that all works. You just need to know how to use it to your advantage.
So, final question for you, Mikkel, and further to Simon's analogy around the air conditioning unit, the difference, in my opinion, between a services provider and a solutions provider, a couple of letters change, but such a big distinction in the marketplace for AWS or Azure partners. The difference is a solutions provider is the company that comes and recognizes that you need air conditioning and installs it, helps you choose the right model. The services provider is the one that comes and fixes it when it breaks and is responsible for maintaining it for 20 years. And they'll sell you an HVAC system, and they'll sell you some carpets as well. That's the philosophical difference. Where is left for the MSP, the managed services provider, to evolve to become a managed solutions provider over the next 5 years?
I think you said it already all. There's not much to actually add to that, except for closing off with you accusing me of being philosophical before. So let me close with another philosophy, which was a guy every IT engineer should know, and that's Edsger Dijkstra, who said the highest art of IT engineering is the separation of concerns.
Say that again?
Separation of concerns, and that's what we see right now with Amazon and the pivoting towards solution providers. Is the concern of Amazon is not to provide solutions, but to improve and specialize on their primary concern to deliver IT resources. The concern on top of that has a natural transition, a natural barrier, if you like, is that of the solution provider. And solutions always have added value. This is where the MSP comes in. Their concern is to make sense of the multitude of services offered that are generic, and to package them into something that makes sense and makes value for the customers who use them.
It's a bright future for the MSP channel, where Just like Lego, the only way for a partner to make money is by rearranging the blocks in different colours.
To an extent, I think as we talked about, as various skills move out of businesses in the IT department, I think we'll find that there will still be a need for a high-level strategy and high-level thinking. And I think that's where MSPs can add real value there, because by as a sort of virtual CTO, virtual CIO within an organisation, we get to know businesses, we get to understand what they're trying to do, we can help them make decisions about where they're going to go. It's not necessarily our own MSP services, it could be almost anything. But almost every company now is a technology company in some way or another, whether it's because you've got a small shop on the high street, but you need to use social media, you need to use, you want to be able to sell online, you need to take part in a supply chain somewhere. Or if you're a much bigger company, a manufacturing company and so on, you've got a load of IT systems that help you do that more profitably. So every company now is a technology company. And I think the smaller companies, with only a few hundred employees, may not have the resources to be able to hire those high-end sort of strategic resources, so they can get those from an MSP as they need them.
That's a brilliant point to end on. The friction between the way buyers want to buy and the way vendors want to vend means that channel partners, cloud partners, such as managed services providers, are vital to actually do it well. And I think the fundamental reason why customers come back to us, it's for one simple reason. We have a specialization that you don't.
Yep, absolutely.
That's the value. It comes down to the commoditized infrastructure or commoditized services. All of that is something for someone else to worry about. But the fundamental reason why people keep coming back is I don't have that specialism, but the MSP does and should continue to hold it.
Absolutely.
And I think that will be a universal truth, no matter what trends come out of computing and technology over the next 5 years. We will always need specialists, and we will always need a place to come when you need to trust something be done right. This has been a fantastic discussion. Thank you very much, both.
Thank you very much.
Thanks, Frank.
Thanks, Simon.
Thanks, Frank. Cheers.
And
Cheers.
we'll catch you next week. Thank you very much for tuning in.
Thank you.